Okay, we're going to be looking at some skills that you've learned in intermediate algebra that you're going to be needing for Chapter 8. First type of thing that we're going to be looking at is simplifying radicals, where I have the square root of a negative number. So when you have a negative under that square root sign, you know that that is an imaginary number or non-real number. And we need to break that negative 13 up into negative 1 times 13. So I can rewrite that as negative 1 times the square root of 13. Square root of negative 1 is I. So I have I times square root of 13 for my answer. Problem number 2. I have the square root of negative 36. Again, I have a negative under the radical sign. So I can automatically know that I'm having an imaginary number. And I can break this up into negative 1 times the square root of 36. Square root of negative 1 times the square root of 36. Square root of negative 1 is I, and the square root of 36 is 6. Now, one thing I do want to point out with the difference here between problems 1 and problem 2 is that when you look at the number that's under the radical sign and just look at the absolute value here of 36 and over here 13, you know that 36 is a perfect square, 13 is not. If what you have here under the radical sign is a perfect square, ignoring the negative, then you can just stick this into your calculator and get your answer as long as your calculator is in the real number mode. If you cannot stick square root of 13 into your calculator and get an integer answer, you're not going to be able to stick in negative square root of 13. Or sorry, square root of negative 13. Okay. So problem 3, I have the square root of negative 27. I can't stick 27, square root of 27 into the calculator and get a nice answer. So I can't stick this into the calculator and get an answer with the negative. Right? But I can simplify this. I can write this as negative 1 times 9 times 3. We spent quite a bit of time taking 27 up and breaking it up into 9 times 3. So I've got the square root of negative 1 times the square root of 9 times the square root of 3. Well, the square root of negative 1 is I. Square root of 9 is 3, and put it up front, and then I have square root of 3. Right. Problem 4. Square root of negative 60. Why don't you pause the video and try to do that one on your own. Okay, here is your answer for problem number 4. All right, problem 5. The first thing I need to do here is to simplify this radical. And I can rewrite that negative 20 is negative 1 times 4 times 5, and all of that is divided by 4. The square root of negative 1 is I. The square root of 4 is 2. Skipping a step in here. And all of that is divided by 4. Now from here, there's a couple of different ways that you could do the problem, but the easiest way probably is to look at this term, this number, and that number, and find your greatest common factor of all of that. And the greatest common factor is 2, so I'm going to divide all of those by 2. So I have 3 plus I times the square root of 5, because 2 divided by 2 is 1. I don't really need that 1 there. And then 4 divided by 2 is 2. there's problem 6 for you. Why don't you pause the video and try to solve that one on your own. Okay, there is your answer for problem number 6. Okay, problem number 7, we're going to start off the same way. We're going to simplify what's under that radical. So I have the square root of -1 times 4 times 5. And that is going to give me 2i times the square root of 5 divided by -6. And from here, there's a couple of different things that I can do. I'm still wanting to concentrate on the greatest common factor of the -4, the 2, and the -6. Well, the biggest number that goes into all of those is 2. So I'm going to go ahead and divide all of those by 2. And let me scroll down here so I can get some more room. Dividing all those by 2, I get -2 plus I times the square root of 5 over -3. Now, it seems like that would be a fine answer because there's nothing else that goes into all of those numbers. But my math lab does not like negatives in the denominator, so really we need to get rid of that negative. Now, I could have done this up here in this step. Instead of dividing by the greatest common factor and a bit being a +2, I could have divided all of this by a -2 and taken out the factor of 2 and the negative all in one step, but that can get kind of confusing. Now, there's a couple of different ways to think about getting rid of this negative. I could divide a negative out of all of those. I can multiply numerator and denominator by -1. The easy way to think of this, in my opinion, is just that all those signs just change. So 2 minus I times the square root of 5 divided by +3. Okay, here is problem 8 for you to try. So pause the video and then come back and see if you got the right answer. Okay, there is your answer for problem number 8. Okay, problem number 9. What's different about this problem is that I have a plus and a minus right here. And that's just a shorthand way of writing two answers together. So I'm still going to start this problem off by simplifying this radical. So I have 25 plus or minus the square root of 100 times 2, and that's divided by -15. Square root of 100 is 10. So I have 10 times the square root of 2 up here in the numerator. And again, I have two answers here. And because I have a square root of 2, I have an irrational answer, two irrational answers. Okay, now, 25, 10, and -15 there all have a common factor of 5. So I can divide all of those by 5 and have 5 plus or minus 2 times the square root of 2 divided by -3. And again, my math lab doesn't like negatives in the denominator, so I'm just going to divide out that. And there is my final answer. Oops. Okay, with this problem, we're sort of putting everything all together. I've got a plus or minus here, so I'm saying I have two answers. and I've got square root of a negative 24, so I've got imaginary numbers. So I have negative 8 plus or minus the square root. I'm always starting with this radical over here first. And remember, I'm trying to break this up into a perfect square times another number. The biggest perfect square that goes into 24 is 4. Now, you cannot just break 24 up into 8 and 3 or 2 and 12. You need to break it up into a perfect square times another number. And this is going to give me 2i times the square root of 6 when I simplify that. And I can divide all three of these numbers here. Trying my highlighter up here. The negative 8, the 2, and the negative 10 are all divisible by 2. So that gives me negative 4 plus or minus I times the square root of 6 divided by negative 5. And then once I get rid of the negatives, divide all of those by negatives, I have 4 plus or minus I times the square root of 6 over 5.